So the future of home manufacturing is brighter than ever, and it may actually save American manufacturing. Here's why. So on the screen is the release of the Prusa i3, which was in 2017. You can see this machine cost $900 for a kit that you had to assemble yourself, or $1,200 for a fully assembled machine. Now back in the day, these machines were excellent, but think about how far we've come in less than 10 years. So the first printers were pretty much novel home use machines that would print PLA and PETG, and at the time, these parts were hardly functional. And this was also a steep price for the home user. So then came Creality with the Ender 3. Now I think this machine released at $200, so this would get you, and I had one of these so I can say, nowhere near the reliability of the Prusa, but for like a quarter of the price, this is what created the original print farms. And I had two of these printers at one time printing my parts, and they were okay. It taught us a lot about how the printers worked and definitely how to work on them, because we had tons of failures, and I know some of the Prusa users had failures too, but they were a much better machine, although at a much higher price. So then came along Bambu Lab, who caught the world by surprise with the X1 Carbon combo with this AMS that was just crazy at the time. You had this automatic filament tool changer that you could do multicolor or multi-material prints, and this thing was $1,500 with the AMS, or $1,200 by itself. So go back to the price of the Prusa MK3 at $1,200 for a turnkey Mark III, or $1,200 for a turnkey X1 Carbon. The X1 Carbon was crazy awesome at the time. So I did not buy the Bambu X1C. I couldn't justify the cost coming from like a $250 Ender 3 V2, which is what I had at the time. So I bought the P1P. Now the P1P is not really even relevant anymore because the enclosed printers got so cheap that basically we're going to skip way ahead, but the P2S has basically obsoleted the X1 Carbon, and they no longer make the X1 Carbon. But at the time, the P1S combo I think was $799, and for me with my Enders, this was a huge step up, but also a huge step up in productivity, and I should have done this way earlier. So you take that cost, you can buy this machine now for basically $600 shipped to the house. You get a fully enclosed machine with 4-color, 4-material, however you want to use the AMS. Just consider that the Prusa Mark III back in the day was twice the cost of this, and you would always rather have this P1S. But for an apples to apples comparison, let's say the Prusa Mini, the Ender 3, whatever, you've got the Bambu A1 Mini and the Bambu A1. Let's go with the A1 Mini just because it is an awesome value for a first printer. Remember, the Ender 3 was almost all of our first printers. So you had an Ender 3 at $200, and now you have an A1 Mini that can do 4-color or 4-material. The material is questionable, but 4-color for $300. This is insane, and this is the point now where I say 3D printers are basically like a washer and dryer. And I know we said that way back in the day. Everyone would have a 3D printer. Everyone would be able to make stuff at home if they could do CAD and program the machine. But we're here. For $300, you can make parts at home. And this is revolutionary in the manufacturing industry, in my opinion. And that's why I wanted to talk about this topic today. Okay, whoop-de-doo. We've talked about machines that can print PLA and PETG. What about industrial manufacturing at home? This is where Bambu hit it out of the park with the H2S, in my opinion, and also another machine that obsoleted the X1 Carbon. So I have one of these at home. I put over 1,000 hours on it. I can print almost everything in the world that's offered except PEEK. PEEK's a crazy engineering material, but anyway, this will print almost every material on the market, and look at this price point. Remember the price point of the Prusa assembled back in the day? $1,200. So you can have the AMS2, twice the build volume, and you can print any material in the world enclosed for just a little bit more money. This is where I'm saying the industry is at a revolutionary point of 3D printing, and at this point, almost everyone that's technically competent could go buy one and be successful with it. So one thing that's made everyone so successful that does like this turnkey machine is like, yeah, we all enjoyed messing with the Prusas and modding and the Enders and all these modifications and stuff. But in reality, if you're in a production environment, we all want a turnkey machine. And that's where Bambu stepped in front of the pack. Now another company that's done the same thing, and you can argue about these are the Apple of manufacturing basically. They've created a turnkey machine that's not very modifiable, which some people don't like, but you have a turnkey machine that's polished, looks good in your house, and they just work. So the next company that did that, and that's another controversial topic, is X-Tool. So I'm going to bring up the X-Tool metal fab, which is insane. This brings a laser cutter that will basically do plate work and also a laser welder, and you can get this thing with the full combo for like under 10 grand. And that is just completely unheard of. But when X-Tool started out, they just offered basic lasers and a nice user interface. And that's why X-Tool is one of the biggest companies in the laser for home use now. They've done exactly like Bambu. So follow the trend, get turnkey machines that look nice, have a good software interface, because let's be honest, all the hardware is pretty similar, but it's the user interface that we as the user actually are satisfied with, not whether you have a 15mm linear rail from XYZ company or ABC company. That doesn't really matter. They're going to be comparable. It's the software is where the rubber meets the road. So I want to continue on the laser discussion a little bit. I've got the X-Tool F2 Ultra pulled up, and this is where X-Tool was revolutionary in their market, in my opinion, because they offered a fiber laser that was completely enclosed and safe to use around your family members that don't understand industrial equipment, around your pets and things like that. They did that with the F1 Ultra. They released a dual diode and fiber laser, which was pretty much unheard of at the time. You had companies that offered wide open fiber lasers that could engrave metal that you could look at and burn your eyes out around your pets and everything. No exhaust, just kind of nasty. X-Tool's done the same thing. They've made a polished product that's good for home use and even industrial use with the F2 Ultra. This thing will even cut pretty thick metal. So this is revolutionary, and for the price, you're looking at basically 5 grand for a 60-watt MOPA fiber laser and also a 40-watt diode laser. This is pretty revolutionary. And one of the things, like I said, that's made X-Tool so successful is their software. They've got their camera and their AI functions that automatically lay the material out for you. Now, these are arguably not excellent, but it's better than anybody else can offer. This is the turnkey solution that everyone wants, and that's why this is successful. So I'm done with printers. I'm done with lasers. Let's talk about CNC machining, CNC routers. That was pretty much the topic of this video, and this was just the intro. So let's get into it. So we're going to start with things that are arguably CNC machining. These are CNC routers, and this is basically all that's been available for the past 10 years. I'll bring up a couple, but this is pretty much what the average user in a non-industrial environment could buy. So this is the typical aluminum extrusion, lead screw, maybe linear rails if you're lucky, machine. This thing can barely cut wood, and you get like a router spindle that's 200 watts, functionally useless. These have been all over the market. If you look for a quote CNC machine, this is what you're going to get. Look at the price tag. Okay, that's super cheap. These are useless. I would not buy one of these. But lately, companies have noticed there's a gap in the market. So this is a machine with ball screws, linear rails, closed loop stepper motors, although weak stepper motors, and a 700 watt router spindle. This is a little bit closer to what we're asking for a home CNC machine. And when I say CNC machine, I don't mean cutting Inconel in your house. I'm talking like, we just want to cut plastics and aluminum and maybe a little bit of steel work. Nothing crazy. So this machine, ball screws, linear rails, as you can see, this would be a pretty accurate machine for maybe cutting aluminum. This is a step in the right direction, but you're looking at $700. This thing doesn't really have a controller on it. No chip control. You're going to get chips down on the linear axes. The controller's wide open to get chips built up in it. It's loud. There's no coolant. There is a function for an air blast, but no coolant. And this thing's not enclosed. So you're going to throw chips all over your house or all over your garage. To me, this is still not really useful. Although people have done pretty impressive stuff when they upgrade these machines, upgrade the spindles. They have cut aluminum successfully. It's just messy and noisy for me. So let's move on. So getting out of routers, the focus of this video is the benchtop or garage CNC milling machine. So the first to market, and this was in the early 2010s, maybe mid 2010s, was the Pocket NC. This was a, quote, 5-axis machine. I'm not really sure how rigid it was. I never had one. But it had a super small, high RPM spindle for basically engraving, but it would do slow machining of parts. This machine now costs $7,500 and has a tiny work area. To me, this is a very niche machine and almost useless for my application, but I did want to mention it that it was kind of the first to market. And notice, it's not enclosed and doesn't have coolant. So then we got the Sheriff DMC. The Sheriff DMC was a decent machine that still had issues, but the DMC2 was quite a step up. Now, as you can see, this is the DMC2 Mini, and this is a comparable work size to the machines we're going to talk about. On the topic of rigidity, I'm personally looking at smaller machines because these cheap, lightweight machines are not going to be rigid the bigger they get. So we're going to have to deal with the small work area. But anyway, the DMC2 Mini kit, not assembled. They don't even make the assembled anymore. Just the kit is $2,500. It is enclosed. It does have coolant, but every single nut and bolt comes in a box, and you have to assemble this machine. The downfall to this machine, while it does have flood coolant, a pump, reservoir, fully enclosed, high power spindle, ball screws, linear rails, for one, it doesn't have an X-axis way cover, as you can see, which is not a good idea, and chips are going to build up in that and wear that out. Also, the other downside is this machine is made from tube steel. The tube steel is not machined or ground or anything, so there are reports of accuracy issues right out of the box. After you spend 80 hours to build this $2,500 machine, it won't even cut square. This is a good machine and people have had luck, but you almost need another milling machine to square this machine up, which is not realistic if you're starting out in your house. So next came the Make-Era, Carvera, Make-Era Air, Make-Era Z1. We're going to focus on the Carvera today because it's kind of their high end. We'll also talk about the Air. Let's just say we're going to keep the Z1 out. The Carvera and the Carvera Air are kind of their two high-end machines. I want to focus on the Carvera because it has a tool changer, which is pretty revolutionary. So you have air blast functionality, a tool changer, but you have a super low horsepower spindle. It's a 200 watt spindle. You also have probing and auto part location, which is pretty killer. I forgot to mention the DMC2 does have it also, but these are pretty revolutionary compared to some of the other cheap router style machines. So this is going to be the first machining video. There are great videos out there for the DMC2 Mini, but with all the assembly issues, I don't really think we're interested in that for a, quote, turnkey machine as we've talked about before. So this is the Carvera Air from DG Craftworks, and there's a couple mods to this machine, like a fixture plate from Saunders Machine Works, which I might get into later. They're mod vise, and it also does have air blast, as you can see. So here's a video of it roughing aluminum. To me, this is the first, quote, production application that we've seen. And we are removing a decent amount of material here. You can kind of hear the machine struggling a little bit with its low power spindle and low rigidity. But this is an application where this could be useful and you could remove metal in a timely manner. So around the time that this video came out, I was actually looking to add CNC machining to my 3D printing and laser engraving services at home, but there was really not a machine. I was interested in the DMC2 Mini, but after all the horror stories, I didn't have another milling machine to square the machine up, so that was off the table. Then I looked at the Make-Era machines, and while this is pretty impressive, there was a new frontrunner in the market, in my opinion. And this was a huge gamble because this was a Kickstarter. So let's take a look. So I happened to run across this machine on Kickstarter, the Nestworks C500. Now, like I said, I've been an early adopter to 3D printing. I've been an early adopter to laser engraving. Not such an early adopter to CNC machining, but definitely benchtop CNC metal machining at home. This is an early adoption because this is something I had personally never seen before. So I was willing to take a gamble. Now this is old stuff from the Kickstarter, 800 watt spindle, tool changer, coolant, which was big, and also this is a massive machine at 200 pounds. It weighs even more now at the final production unit, but when the Kickstarter started, this was a heavy machine compared to the rest, and it also had a probe. And they claimed they had this revolutionary smart cam, which is basically AI assisted cam, which we've learned now is actually legit. So at the time, this is all the information we had, was this marketing stuff. So I backed the Kickstarter. Now, was that a good idea? I still don't have the machine, but there are future videos now of the real production machines where I think this thing is going to be killer. So let's look at it. We're going to scroll through the Kickstarter just so you guys can see basically all we had to base off of. Here's the tool changer. ER call it spindle. This is not the case anymore, but this is what we were originally shown. Tool setter, as you can see here, and also the probe in all three axes, just like that. So while this machine looked promising to begin with, we never had any aluminum machining or any metal machining videos at all. And this is the video that sold me. As soon as I saw this video, I pledged the Kickstarter. So you can see we're roughing aluminum with coolant. Now, these are not huge chips. It's a little noisy, but this is something that we hadn't seen in the market. So you notice you have way covers on all axes. The tool changer's closed up. Pretty good machine lighting. The machine's cutting pretty good, and the coolant looks to work pretty good. This was all it took for me. I was willing to take a gamble. So I'll throw up some generic machining videos from their YouTube. I have asked for permission to post their super top secret Discord stuff for all the Kickstarter backers, but I have not got approval to do that. So out of respect for them as a company, and they have some trade secrets and some patents and stuff, we're going to keep that private unless I get permission. If I do get permission, I will definitely post some more content on this machine, but as of now, I'm just going to post what's public and kind of talk over it. So how does the Prusa Mark III tie into a CNC milling machine? I basically wanted to create the discussion of how these home manufacturing tools have evolved over the years, just like I alluded to the washer and dryer. When the washer and dryer came out, it was a novel technology that was almost a luxury. The 3D printer came out. It was a luxury. Now everyone has one. The laser engraver / laser cutter came out. Super dangerous. Now a lot of people have one. I have one. It's very safe to use, very polished. It's in my living room and looks pretty nice. So do my 3D printers. I just basically wanted to make this video to compare the current state of household or garage CNC machining to what 3D printing was 10 years ago. I mean, just look at how polished this machine looks. This thing could sit in your living room and just work. Now, granted, it may be a little loud. CNC machining is louder than 3D printing, but this is a revolutionary time to be alive. And as an early adopter, I think you should be an early adopter of one of these new CNC projects, because why not bring American manufacturing to your house? So I could go on, but I won't. Long story short, I've backed the Nestworks C500 on Kickstarter and will be adding CNC machining to part of my capability. I really hope this has been a good start of the discussion. There's not a lot of content out on this machine. Please like and subscribe. Even comment what you want to see on this machine. I will probably be receiving this machine around September, and as soon as I get it, I already have plans on videos, and I will definitely start focusing on more machining content as soon as I get this. But for now, I'm going to keep giving you guys updates if I'm allowed to from the company, and I'll also continue to do 3D printing and laser content. So please subscribe if you like this home manufacturing, and as always, my goal with this space is to become the most ridiculous home manufacturing space that I possibly can. So thank you guys for watching, and we'll see you next time.